Welcome back to Advent of Code. Today working on day 8, 2021. Let's just get right in. So today we have something about 7-segment search. So we have a 7-segment clock. So that's it. That's 7 segments. And the problem is that the wiring has been messed up. It's not clear what happened, but we just have these weird things that say some stuff about the numbers. So what I would like to say to start, first of all, you know what? Let's take the small input. I think it's not useful actually, this one. So let's take the actual test input. We put that in day 8. We take my template, we put in day 8, and here we just do the parsing first. So to do the parsing, we're gonna have to there is a dash at the end of the line. I think this is let's just make sure this is if there is a line return or not. Okay, there is no line return. So here there is a problem. We need to fix that in this input because there is a line return here. So we're gonna fix that right now. We say we say here line when there is a dash, you don't do a line return. Yes, that's it, like that. Okay, so that's already a first little thing, and you need to be careful. We want to use this kind of input. So actually, you know what? We're gonna save that here in another file. We're gonna just put that just to make sure we keep that on the side. So now here we need to split a new line, remove the empty line, and instead of parsing each line into a number, we need to do some more complex thing. So here we have a line. We need to do const in I don't know how we call the left hand and right hand. Let me just check the frame statement. Okay, so what we have on the left is the signal patterns, and on the right is the output value. So signal patterns, output value. So here we have to do line that's split, and here we do like that. So basically we want to split, just get the right and the left, nothing crazy. And here we can return signal pattern. Here we want signal pattern that's split on the space, and output value we want to do the same. So actually let's write it here, map, oops, we do x dot split on space, and that's it. Here we have our two values that we return. Perfect, should be good. As always, I like to use the log to make sure we have the right data. Now day 08.js. This looks correct. Perfect. So we have our input parsing, which is the first step. Second step is I want to just do a little bit of thinking around these numbers. So we have here we're going to say the number, and here we're going to say number of segments. So for example, 0 has 1, 2, 3, 4, 5, 6 segments. 1 has 2. So that's going to be very important to really understand that correctly. So 1, 2. I'm going to speed things up. I'm going to write everything. I'll be back in a second. Okay, I'm done with that. So basically, took the number and For number 0, it has 6 segments, which is the same as the number 6 and the number 9. Number 1 only has 2 segments. Number 2 has 5 segments, which is the same as 2 other numbers. 4 is fine. And I think 7 has 3, it's the only one, and 8 has 7 segments, it's the only one. So that's just like a good way to really understand the problem deeply. And now we know actually we just land on the same conclusion that 1, 4, and 7 are really the easy one. So this is this one. 1, 4, and 7, is that it? 1, 4, 7, 8. So those numbers are the easy one that we need to tackle. So let's do just that. Sorry, I'm just having some trouble. Technical issue, but yeah, we're good. So we just need to count the number of digits. That should be easy. And how many times do digits 1, 4, 7, or 8 appear? That looks something that's quite easy. Here we just need to let counter start at 0. We do a for off, line of lines. And here we need to do line dot output values. We need to filter so that the value v dot length so here we need to do, so it's either 2, 4, 3, or 7. 2, 4, 3, 7. Those are like the number of segments that are interesting. I need to make sure that v.length is one of those. So we filter, and then we do const matches, and here we do counter plus equal matches, and we log counter. That should be it for part 1. So that was good to just like spend a little bit of time just count the segments. Let's see what happens. Oh, matches that length. We have 26. That's the correct answer. So now we can take the full input here and just make sure we have the right thing for part 1. Okay. That is correct. Let's go to part 2. I'm going to read that now. Okay, that's perfect. Now we need to actually understand what each of these numbers is. That's great. That is great. We might need to sort the letters. I don't know. Because, yeah, actually, we might. Yeah, I think. Let's just start by copy pasting the input, the small input. Oh, there is again the problem with the line return. That's good. You have to be careful about that. So now we have to do this kind of mapping. So this is kind of like a Sudoku, you know. You have to deduce from things, deduce some things from other things. So we know for sure, we always know 1, 4, 7, and 8. That's one thing we know for sure. So here, first of all, we need to go through each line. Sure, so we're just pasting that here. We know, so we said we know, actually I'm going to copy paste that. here so that we always have it in our vision field. So we know about 1, 4, 7, and 8. Now we have to deduce from these. So there is 3. So if it has length 3, oh wait, actually, one thing I need to check is this. Is it always the same, or oh yeah, it doesn't appear in the same order on the left, right? This one, C, D, F, E, B, C, D, F, E, B. Okay, so to simplify things, we're going to sort always these things. Otherwise, that's going to be a mess. So here we're going to do dot sort. Is that working? I'm not sure. Let's see. Oh no, wait. We split. And then here we map y dot sort return y. That's a bit convoluted. Y dot sort is not a function. Oh yeah, we have to y, we have to say const letters equal y. Let's rename y. We say string instead, and here we letters dot sort, and we return letters dot join. If we do that, here I'm gonna have to log the lines again. I just want to make sure we have things that are sorted. B, C, D, E, F. Yes, 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 yes. Everything is sorted now. So instead of having these numbers in random order, we're going to have sorted numbers. That's just one thing to simplify the input and not think about that aspect. So here we need to find, we're going to say const matches. We need to say, okay, for 1, this is line dot signal patterns dot find such as x dot length is equal to 2. We're going to do the same for 4. We're going to do the same for 4, 7, and 8. 4, 7, and 8. 4, it is 4 segments, 7, it is 3 segments, and 8, it is 7 segments. Okay, that's one thing. Yeah, I'm just thinking, like, is it the right order, or should I put this? Yeah, that's fine. So now we need to deduce things. We have that filter such as x dot length is equal to 3, and no, wait, not 3, 6. 6, so that's for the numbers. Length 6 is the numbers 0, 6, or 9. 0, 6, 9. And for the length, no, not length 3, length 5, we have 2, 3, and 5. 2, 3, and 5. So here we're going to have to hard code some kind of thinking to make sure we do the right stuff. So one thing we could do is just try each option to say, so maybe we're going to have to do that, but let's focus. How can we find the difference between 0, 6, and 9? So for that, given we know 1, 4, 7, and 8, so the difference between 0, 6, and 9 and 8 is just one segment. It's not really useful. One thing that's going to be useful is that if a number doesn't have both letters from 1, then we know it is 6. Because you see 1 has these two things. They are both in 0 and in 9. So that's one thing. To know 6, we just have to find the pattern in this that misses one of the two letters from 1. So we're going to do that. It has length 6, and how do we do that? It needs to miss one of the letters from 1. So we need to say x dot includes matches of 1 doesn't have that. So matches of 6 is equal to that. I think we should console log line. Oh no, not see, yeah, line and matches. So we're gonna see what happens now. We're saying, okay, no, we need to say not filter, we need to say find. Find is returning the first element that matches that. That's what we need. Okay, so here, okay, line, we don't care about line. Here we say 6 is B, C, D, E, F, G. It has B, but it doesn't have A, so we know this is 6 for sure. So we are good. Now we know here we need to say this and x is not matches of 6. And here we know this is just 0 or 9 here. So we are progressing. Progressing slowly, but progressing. So basically what I'm trying to do here is solve the problem like as a human, and then it should get us in a good position. So let's see, we have 0 and 9. So here, everything in 4 is in 9, but it's not in 0. So we're going to do the same. We're going to say matches of 9 is equal to this. And what's happening here? We say we need x includes, we say x does include everything from matches of 4. Yeah, we say, and right now, right here, the includes function, because we have sorted the strings, we can use the include function because we know that these letters like B, C, D, F are going to be a substring of A, B, C, D, F, G. That's just like the magic of sorting the strings. I'm really happy we did that. So now we know this one is obviously 9. So here we just have to say, and x is not matches of 9. And here we have matches of 6 of 0, sorry. Oh, I was close to make a mistake. Okay, so we solved the first, like, we solved 6, 9, and 0, and now we need to solve these. So we have 2, 3, and 5. So we're just going to be doing the same. 2 and 5 and 3. So 3 has 1. So that's simple. I'm just going to copy paste that. We're going to say 3, the length is 5, and it includes matches of 1. That's it. That's solving for 3. And now we just have 2 and 5. And we can use any number for that. So actually 2 and 5 are gonna might be a pain. Oh no, 5 has no 6 includes 5. 5 is a substring of 6, so we can do that. We're just gonna copy paste that. We want to find 5. So here we just have to say this, that x is not matches of 3, and we need to say 5 is a substring of 6. So we need to say matches of 6 dot includes x. So as you can see, this is different than here because yeah, we're just doing the opposites now. We want to we say 5, yeah, sorry, 6 includes the string, the substring 5. Hope this is clear. If not, like don't hesitate to write a comment asking for more details. And now we just have 2 remaining, the number 2, and we just have to say, okay, here, oops, sorry. We just have to say, okay, x is not 5. So now we're gonna display the matches only. We can remove these comments because we have the comment above in our file. And now if we display that, okay, that's interesting. We have undefined, so we have a problem somewhere. Okay, here I put filter instead of find, so we need to use find here. Let's see. Oh, we have the problem for 0. There might be a problem somewhere. Okay, we have 2, 5, and 9 that have a problem. 2, 5, and 9. So let's check that. So now is debug time. We want to make sure we didn't make a mistake here. So actually, I'm going to go back to filter here, and we should always have 1 value in 6. That's correct. So here we can do find. If we do filter in 9, we get no value. So we say x include matches of 5. So maybe this is the opposite. Maybe I made a mistake here. So matches of 4 is this, and x is 9. So 9 should, oh wait. Oh, I think this is not correct. I think the include is not correct. That's my bad. Include is not correct because yeah, the string. So basically, if you have B, C, D, F, and here I have B, C, D, F, but let's say instead of C here we have A, then this is just messing everything. I was making a mistake. So here we need to compare sets instead of comparing strings. That's going to be a bit more annoying. So we're going to create a function here to compare. Function includes A, B. A includes all from B. So we're going to say const. So here, basically, we have two strings, and we want to check if one string contains all elements from if the string A contains all elements from the string B. So A is, that's the list. So in order to do that, we're going to create a new set, const set new set A, and here we're going to return B dot every set that has X. So here I need to double check this is correct, but we are using some fun stuff here. First of all, we are splitting the string A into elements, and then we are creating a set. Set is really cool. It's just like a bag of elements. You can add elements to this bag, or just check if there is an element in the bag. That's constant time. That's really great for use case. B is so we need to check that everything that's in B is in A. So we need to check, we need to use the function every to make sure this callback passes for every element of B. And the thing is, we say A has the character X. Okay, so that sounds correct. Now we have to use this in the right way. So we want to say, okay, includes, we say we don't want X to be included in matches of 1. Is that correct? I'm just afraid to put things in the wrong order. We need to be careful here. So here we have 6 and 1. 6 and 1. So we need to say that, sorry, 6 and 1. We say that all elements from 1 are not in 6. We do that. We say check. So 1 should be here and 6 should be first. So say 6 and 1. So that is correct. So the good thing now that we've learned is that we can use the function like that without changing based on the previous way we were thinking about things. Includes X matches 1. So here I'm just replacing things. Include X matches 1, and here includes matches 6. So here, just like a find and replace here that I'm doing it manually just to make sure everything correct. Okay, that looks good. Now we're going to try that again, and we still have undefined in some places. So here what I'm doing, I'm going to use filter just to make sure we have just one value for 9. That's correct. And we should have just one value for 0. That is correct. So it seems that we fixed the problem with 6, 9, and 0. But now we have a problem with 3, 5, and 2. So here we're going to filter. We are sure there's just like one option for 3. This option is this one. Now for 5 and 2 are both empty. So doesn't work. So we need to say length is set to 5. And no, I don't need this one. I just need to say, okay, I don't need this one actually. Haha, that's the problem. And just to say this is length 5, this is not matches of 3, and there is this condition on top of that. And here just say this is length 5 and this is not 3 and nor 5. If we had that, this gives us a full object here. Now we just have to get the values in the right order. So we actually have to reverse the object. So one thing we're gonna do, we're gonna say matches dot, no, it's object dot entries, I believe, from matches. We're gonna log that. So basically object dot entries is a nice thing that takes an object and creates an array of things. Here we just have to map and do x.reverse. So now we should have the same thing, yeah, but the opposite. And now we can just say objects.from entries, I believe. And now we have, yeah, okay, that's perfect. So see, at first we have an object with 0 and the corresponding value. And now we have the corresponding value and 0. And this is something that's perfect because we're going to be able const translation table. We're going to be able to do to use line dot signal patterns dot map signal, and we can say, okay, the signal, we just have to take the translation table of signal, and this gives us the value. We then just have to join these values together, and this give, why do we have 0 here? Maybe that's from part 1. Yeah, this gives us the huge number that doesn't look right. Oh, this is not signal pattern that we want to translate. We want to translate actually the output value. Because here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's correct. And here we have 53, 53, which is what was expected here. I think we don't need to, oh wait, we need to add all of the output values. Okay, so we're gonna do that. Now we're gonna take this sample that I've saved. Oops. So remember a little bit earlier, I've saved this sample. Up, we're pasting it here. Now this is const translated, gives us this. Now we can say, here we can say let total equals 0, and here total plus equal translated, and then we log the total. There is a mistake here that looks, yeah, okay, so here this should be a number instead of being a string. Instead of adding string together, concatenating strings, we want to have one number. That looks correct, I think. 61229, yes, that is correct. I think we're in a good position and we must have the right answer here. Let's just double check, because it's always fun to submit and get the success. We've got the right answer. That's perfect. Thank you very much for the support in this series. One more time, I'm really enjoying reading the comments and everything, so thank you so much. Please don't forget to drop a like, comment, and a subscription, and see you in the next one. Bye bye.